All right. Well, good morning, everyone. My name is David Conway. I'm product manager for various parts of Android. I specifically focus on the Android market in my day job, but I'm going to talk to you broadly about the Android story today. And I'm also very pleased to have Dan Morrill here, who's our lead developer advocate. So he'll be jumping in as well. Here's what we're going to cover: the open platform and the market. Dan's going to go deep on writing Android apps and a bunch of interesting technical aspects of that. And then I'll go to some demos, and we can do questions at the end as well. So Android is an open platform. And when we started out thinking about how to do this, we realized we really had to take into account all the sort of major stakeholders and aspects of the mobile industry. One is, and you could argue these are two actually, but the industry itself, the carriers who run the networks and have these massive fixed cost investments in networks, and the OEMs who make the handsets that run on them. Developers is obviously a key one, and especially for us as Google. I think our goal overall was to try to, with Android, was to try to really open up the mobile experience that people were having. You know, we had feature phones with J2ME and whatnot, but a lot of the content wasn't compelling. It was highly controlled, a lot of fragmentation and incompatibility. So we at Google, we're a technology company. We really think about developers a lot. And the last piece, of course, last but not least, is users. We really put users at the center of everything that we do. But again, in approaching mobile, you really have to think about all of these. So we think of it as three legs of a stool, and everything we do around Android is to kind of bring this all together to make a successful ecosystem for everybody. So for carriers and OEMs, there are a couple major ways we approach this. One is just giving them a way to ship devices and user experiences without paying for the privilege. Excuse me. So Android is free. It's open sourced. And, you know, I think if nothing else, in terms of just the bill of materials for phones, you have a question? When you say Android is free, the device, the design? Yeah. So the Android, we do not charge for the software, for the Android software that runs on phones. We develop it here. We open source it. We work with partners. We've created this Open Handset Alliance. There is not a $15 per device sort of fee to run the software on a device. And to date, we haven't actually sold the devices ourselves. It's really just working with partners, and we're creating the Google experience on most of them. So yeah, it's, you know, I think in terms of, it lowers the bill of materials cost for the phone itself. So often you get sort of a smartphone at feature phone prices because you're not paying for that operating system cost. And our belief is that, you know, we make money when people use the internet, do searches, et cetera. And so, you know, the more we can get people using the internet, doing searches, the better we do as Google. So this is strategic for us. I think it's sort of similar. The creation of Android is sort of similar to what you may have seen with us in the 700 megahertz auctions, if you remember, a year ago or so, where it was just critical to us to open things up, and we knew that sort of the right things would happen if we did that. The second major piece, as far as satisfying carriers and OEMs, was just giving them a way to innovate and differentiate. And so it's licensed under the Apache 2 license. There are parts of it that are under different licenses, such as the Linux kernels, obviously, GPL. But and we've used various other components too. Our Bluetooth stack is from BlueZ. We use Supplicant for Wi-Fi. You know, there's various open source projects that sort of are part of the entire experience. But the sort of the runtime layer and above, and the apps that are open sourced are all under the Apache 2 license, which is very flexible. I mean, you can pretty much take the code and do with it what you want, and don't even need to contribute it back. So that's our approach there. For users, you know, while the OEMs and the carriers may not necessarily agree with this is more Google's approach to everything. Is we want the users to be in control of their device, so they can install the apps that they like. When an app installs, they get to see what permissions this thing is going to have. So if they don't trust this developer and don't want it to have access to their address book, they don't have to install that app, and they can see that that's going to happen. So we have a permissions model for that. And we want them to be in control of the experience themselves. So you can literally replace entire parts of the device, such as the dialer or the address book. So if you want to substitute in a different component to do different things and handle those calls from other apps, you can do that. And even if you get a bundle of them, you can control sort of which ones you use and which ones you don't. Finally, developers, and this is where Dan and I spend a lot of time. Dan working actively with them on the development side, and me running the Android market, which is really this entire ecosystem to sort of make open distribution work. They can write whatever apps they want, even if they compete with somebody. And they can do what they want with them. They can replace the core components I talked about. They can, they're basically in control. So that transitions really well. Actually, I'm going to jump ahead to the app publishing model for them, for the developers. They're really in control of their content. They're the ones who sign their own apps, and so they therefore are the only ones who have power to replace their apps and phones in the future. There's no approval process. You post something on the Android market, and it is up there in just a few minutes. And really, they're the ones who have the relationship with their users and the customers. So we're sort of running. I'll talk about the broad space. We are running the Android market, which is, it's non-exclusive because you can still install apps through the browser. You can still use a USB cable to sideload it to your phone. But with the market itself, we're trying to create a global applications market that simplifies the content distribution, make sure the right people get a piece of the action so that there's incentives for all to make this a success. And strategically, it provides a really key part to maintain compatibility and prevent fragmentation. You think about what happened with Unix, where things just exploded. With an Apache 2 license, you can imagine that happening. But the hope and the mission is to maintain that compatibility, give people an incentive, and we have a compatibility test suite for devices in order for them to be allowed to have the market, so that if something's on the market, it'll run on your device if you have the device. And in general, the developers have the relationships with their users and can upload what they want. But we do have a YouTube-like model where people can flag apps which they think are objectionable. We don't allow things like adult content and whatnot. And then we have customer service people here that when things get flagged enough times, we review them and sometimes take them down. But it's an after the fact sort of ex post facto model as opposed to a explicit upfront approval process. And then just finally finishing this slide, there's a one-time $25 registration fee for people to publish things on the market. That's really just for us to make sure that they're a real entity and to limit spammy type apps. And just by running a sort of financial check on someone, if they have to have a credit card and an address associated with that and whatnot, we know they're a real entity, and it avoids sort of the spam problem. And they get 70% of the sales. We run this in aggregate as a nonprofit, but we have partners that have vested stakes in making this a success, and there are sort of transaction and distribution fees associated with that, and transaction costs. So with that, I'm going to hand off to Dan Morrill. He's our lead developer advocate for Android. He works with our developers and talks to them all the time about developing apps. So take it away, Dan.
Thanks, David. So, pointed at me. So yeah, who here, has anybody actually written an Android app yet? Fooled around with it at all? Okay, a few people. Cool. So what I'm going to do today is just give you guys kind of an introduction to how an app is written, what sort of the app development philosophy is, and call out some of the more interesting technical challenges that we solved in building this platform. But before I do that, I just want to kind of back up for a moment and ask kind of how do we think about Android? What is Android? So Android is really three things. And the first thing is it's a chunk of code for making cell phone calls. I used to own one of these back in the day. A Motorola StarTAC could very well be the best actual straight-up phone ever made before they started adding other things to them that were not phones. But really all this thing did was it had a little processor in it. You'd start it up, and all it did was just talk to the radio and make this tiny little LCD display that showed you what phone number you were calling. That was pretty much all it did. And so that was the original kind of purpose of a cell phone. And obviously, Android includes that functionality. But Android also includes, like most modern cell phone operating systems these days, includes a fully, competent and qualified TCP/IP stack, a World Wide Web browser, and so on. And so, Android is a full-on, internet client. And this is actually kind of interesting. I remember years and years ago, I think it was probably 5 years ago, I guess, I saw this commercial, and I forget for which U.S. carrier it was, but they had this, there was a woman, and she had this new cell phone, and she was telling her friend about it, and she's like, yeah, this is a great new cell phone. And then the friend asked a question, and the woman didn't know the answer. She's like, oh, well, I don't know. And so the friend gets out, like, his new cell phone, and he says, oh, I'll just look it up, on the internet, and starts doing a Google search. And the woman, the original woman in the commercial, she's like, you can get the internet on your phone? And she said it in this like totally sad, tragic kind of voice. And I just started laughing. I don't know if that was the effect they were going for, but I just started laughing because it was such a non sequitur to me, because I was like, why would you not want the internet on your phone? And so that was 5 years ago. And only today are we really getting to the point where you've got a really excellent, web browser and internet client on your phone. And so finally we're starting to get, where that kind of functionality is mainstream. But of course, the third thing, and perhaps the most interesting thing for this group, is that Android is a platform for running code. Now, I'm being very high level and vague and kind of generic about this. And the reason for that is, we really have three kinds of code. You guys, if you have heard anything about Android at all, you've probably heard that we have this thing called Dalvik, which is this virtual machine that runs managed code. And this is what, kind of the lion's share of Android development experience is like. And you write, your applications using the Java programming language, and they, during a compilation step, are transformed into Dalvik bytecode to run on this virtual machine. Now, people have made kind of the assumption that, oh, well, to write Android apps, you write apps in Java, and that's really not the case. Because we do, in fact, support Ajax applications, who I believe to be the guy on the left. The other guy is Achilles. And you can write web apps, whether it's a straight up web app, that has no native piece at all and just runs on the, inside the browser entirely. Or, we also, as I'll talk about a little bit later, have a mechanism for integrating web technologies and functionalities into an actual Dalvik app. And then, of course, there's the, native code for heavy lifting that currently we support the, for example, the ARM processor, which is what's in most cell phones today. And, you can write parts of your Android applications in native code as well. So I did mention Dalvik. Let me give you, a really kind of high-level overview of what Dalvik is. Dalvik is a virtual machine, running bytecode. It's similar to, the Java virtual machine or the .NET CLR, but it is not a Java virtual machine. It actually has its own bytecode format. It's a, typical, won't shock anybody who's familiar with virtual machines. It's memory protected, garbage collected. There's actually an application development model that has managed lifecycle objects. And then Dalvik, however, the primary reason why we kind of rolled our own virtual machine instead of repurposing or implementing a Java virtual machine or something like that is really because our engineers looked at the the existing virtual machines and kind of realized they don't actually work that well on mobile devices for reasons which I'll get to in just a moment. And so, Dalvik was optimized for embedded devices, mobile phones, and similar things. And as such, it was designed to not really need a just-in-time compiler. And as I mentioned, it does actually have a custom bytecode format and is not Java. So the experience of writing an app for Android that runs on Dalvik is really that, you write your application and you use a number of APIs provided by the system that together with the application runtime environment implement basically just a managed lifecycle object. If you're familiar with the concept of like something like OSGI, or similar kinds of component object spaces, it's similar in notion. They're defined lifecycles for various objects, but it's much more streamlined and lightweight. And so the other thing that it's interesting that's interesting about this model is that the Dalvik virtual machine and the way it runs is actually designed to be fairly closely integrated with the actual process model. And in fact, Dalvik intends that most of the heavy lifting done by the system is handled by native code. So for example, we don't do a lot of graphics operations actually in Dalvik. We punch through to native code for things like 2D and 3D operations. talking to other processes and so on. And of course, all your favorite tools are supported, which is the main reason why we spent a pretty considerable amount of effort in building a set of tools that lets you take Java bytecode and translate this to Dalvik bytecode. And in this way, this lets us allow developers such as you guys to reuse your favorite tools and your existing skills in Java, best-in-class tools like Eclipse, although you don't have to use Eclipse. But we spent a lot of time to try and make sure that we picked a great community with robust tools and, paved the road to make it as easy as possible for them to write Android apps. So I mentioned this a couple times, and I want to take just a few minutes and talk about some of the things that we did for Dalvik. We say this, and people, believe us, but they don't really believe us, if you know what I mean. And what we'll say is, look, mobile devices don't have a lot of memory. And people will go like, oh, yeah, sure. Okay, yeah, that's true that mobile devices don't have as much memory as a desktop PC and they're not as fast. But people usually wave their hands and say Moore's Law. And unfortunately, no, that does not work in mobile. And the reason is that what Moore's Law actually says, as I'm sure you guys in this room well know better than most people in the industry, is that transistor density doubles every 18 months. It doesn't say anything about speed. Speed is what the desktop world, the Intels and AMDs of the world have chosen to use their increased density for. But in mobile, what almost all of the major players are doing is they're using Moore's Law to increase transistor density, reduce die size, and reduce power consumption. So they're increasing battery life. And things like faster processors and more memory is a very secondary concern. And so it isn't really acceptable when you're writing mobile applications to just kind of wave your hands over it and say, oh, well, sure, it might be a little sluggish today, but in 18 months, it'll be twice as fast and then it'll be usable. That just really, that path doesn't work on mobile. And so recognizing that, we went and did a lot of, work on this. So, for example, Dalvik bytecode. Why do we have a different bytecode format than, say, Java bytecode? The reason for this is the Dalvik bytecode, if you look at the Java bytecode structure, it's organized on classes, and it tends to be kind of chunked up, and you jump around a lot in memory when you're interpreting a Java class. In the case of Dalvik, what we actually did was we designed the bytecode format to be very, very flat and shallow so that we can take this, load it into memory once, and memory map it across multiple processes. And this is particularly valuable for the system classes like the core, runtime frameworks, and so on, because what this lets us do is essentially load that memory once, and we only have one copy of the system running, as opposed to loading up the same memory and the same objects for each process or each application that's running on the device. The second thing that we did, and this is an example of another optimization, is we did aggressive inlining. And, aggressive interning. So you guys are, I'm sure, all familiar with string interning, which is where if you've got a string literal in your application and that appears multiple times, the memory for that is actually only allocated once by the compiler and stored, essentially as a global somewhere in this global intern pool. In addition to interning strings, though, Dalvik also does things like interning function and method signatures. And the reason for this is if you think about a method that has two integer inputs and returns an integer, that might be addition for one class, or it might be subtraction for a different class. And all of a sudden you've got this, and even though these signatures aren't huge, you got the same signature, existing in multiple classes in the system. And if you could intern those as well, you can also reduce the memory. Now, of course, the thing here is that we're obviously a lot of these optimizations are aimed at saving memory, and there is obviously a computational trade-off that you make when you do try and minimize memory consumption. And that's actually by design and quite intentional, because what we're doing is recognizing that memory pressure is, or what we call memory pressure, is really the biggest technological issue to building a decent framework like this. And really what this boils down to is this. If you're familiar with a hard real-time programming system, you know that the difference between like hard real-time and soft real-time isn't that hard real-time systems need to run really fast. It's that they need to run really predictably. There are many applications like, say, video, where 30 frames per second is acceptable, and most of the time you can hit 30 frames per second. But if you really needed to maintain that frame rate, you build in a hard real-time system so that you have a guarantee that you can hit your frame rate goal. And it's similar in concept to the way we think about memory. Our metric is kind of how many processes can the user keep in memory at any given time. And if you've got 5 applications installed, and there's only enough memory for one of those applications. And what happens is every time the user switches between apps, something gets shut down, something gets started up. The user spends a lot of time waiting for apps to switch. And so to avoid that, we have as one of the key design goals of the overall system, both Dalvik and the framework, is to minimize memory. And what that does is that allows us to have this sort of minimum number or increase the average number of applications that we can have loaded in memory at any given time. And by doing that, what that lets us achieve is responsiveness and improved user experience and so on. So these are some of the things. And then, of course, the final thing is just, a register-based instead of stack-based VM. What this means is if you look at, in a simple addition, take two integers and return their sum. In a Java virtual machine, which is a stack machine, you don't just have a load A, load B, and then add. You have a load A from stack, so push A onto the stack, push B onto the stack, and then that will eventually end up getting transferred in native code at the actually hardware assembly level into like one read, one store. For each argument that you load off of the stack. And so on a desktop, it's really not that big a deal because you got a just-in-time compiler which can come along and optimize all that away. But on a mobile device, if you actually use a just-in-time compiler, all of a sudden you've now got basically two copies of your code in memory. And everything that I just said about memory pressure means that that's really something that you want to avoid. So all this is why Dalvik has this kind of, I'm not going to call it unique, but very memory-focused and interpretation-focused execution environment. We wanted to make sure that it's sufficient as an interpreter so that it doesn't need a just-in-time compiler. Although that said, we are working on improved features such as an improved garbage collector. I forget exactly what Dalvik's got right now. I want to say it's a mark and sweep, but I'm not sure. But basically, we want to go to one of the more advanced garbage collection algorithms that's been out there. Just-in-time compilation, the team's working on one now, and one of the most recent benchmarks I saw has something about 85% of native speed, which is pretty good for what it would essentially constitute a second-generation VM. And then additional optimizations in the core libraries. Yeah, question in the back. We can't compile to native when somebody downloads the app, primarily because we don't necessarily know what the instruction architecture is that they're running. We could do that, but there again, you end up with two copies of it, and you'd end up with two copies in local storage. So, if you take the original bytecode and then have like a native compiled version of it, and you download that, you've then got to store the downloaded bits somewhere, and that uses up additional storage space that's also limited. I'm sorry, I couldn't quite catch that. That's a possibility, and it's something that we've talked about. I'm actually not familiar with it's come up, and I'm not sure if it was just we don't have time to do that yet, or if there was a different objection to it. So I don't know what the answer to that would be. So the point that I kind of want to make is, actually I had one slide out of order here, so I'll do this one next. So what I wanted to do is then just take another quick moment and talk about, so everything that I just described also is an interesting insight or sort of a glimpse into our security infrastructure that I wanted to talk about as well. And so when you install an Android application, it gets assigned its own unique user ID in the Linux sense. So what this means is that we're not using, a phone is not intended to be a multi-user system. And so we instead use this notion that Linux has of and this is a standard Unix multi-user thing, and we actually use that as application protection. So what this means is we're relying on the Linux kernel, which is very, very well tested to be very good at protecting users' data from other users on the system. And so, in that way, we use application sandboxing, and this goes all the way up. We do the only process in the system that runs as root is basically this thing we call Zygote, which is a copy of the Dalvik virtual machine running as root pre-warmed up. And so what it does is it basically on system boot, this one process starts up and then goes to sleep. And when it gets a message from the system manager saying, hey, install this or run this app, it does a fork, an exec, and a ch user to become the user of the application. And in that way, it's essentially a drop privileges scenario. And instead, we have this thing that we call Binder, which is a kernel level IPC thing that's actually rather sophisticated. It's been, I forget exactly where we inherited it from, but a couple of our engineers wrote it, having based it on similar work that they've done before. And it's sort of a fourth generation IPC system that is really good at passing things like pointers and even file handles and so on between processes. And we rely on that as a sort of enforcement strategy to make sure that any IPC that we do between processes is safe. What's that? I'm sorry, I couldn't quite catch that. So the question was, so what, essentially how are privileges and permissions and so on handled for applications? And the way this works is an application needs to request a certain number of, or needs to essentially state what it's capable of doing. Does it access the internet? Does it read the contact book? What does it require from the system? And then based on that, it actually will display permissions to the user when the application is installed, and the user has the ability to essentially reject the app. So the user can't do like a line item veto and say, give it internet, but don't give it context book, because we can't assure that the app would function, with that situation. So instead, it's an all or nothing sort of thing, but the user is presented with all of the capabilities that the application requests, and the system will enforce the fact that the application can't access something that it didn't declare that it needs. So the final thing that I wanted to talk about real quickly was, you can also do AJAX applications on Android. And so this is just kind of a quick laundry list of, what the browser on the device is capable of. But I also wanted to point this out. We have this notion, as I mentioned, of Dalvik, and you've got your Java namespace and your managed objects and so on living in there. And you can also embed this component called a web view, which is a wrapper for WebKit, an actual little browser component. And you can stick that in your application, and it can display websites and so on. But we also have this thing called Add JavaScript Interface, which is a tiny little method that is actually very powerful, because what it lets you do is inject a Java object into the JavaScript namespace. And so it lets you create what I like to call augmented AJAX, where you can provide additional objects and functionality to your web page running JavaScript that it would not normally have. So that's it for the, whoops. That's it for my technical talk. I wanted to go back to Dave, who is going to show you guys some demos of interesting apps.
All right. So let's go to the projector if we can. Oh, good. Okay. So I'm running our Cupcake release, which is sort of what most users in the world have right now with Android devices. And I just wanted to highlight some of the cool things that the system can do and sort of illustrate some of the things Dan and I have been talking about. Google's a company focused on speed. You do a search and you see how many milliseconds it took to get the search results. We try to apply that in the UI design as well. So, we have this status notification bar. I don't know if you've seen this. Our users love this, where basically any app can put a notification in there that's touchable and actually takes you to the app or some independent activity within the application. And this is not just accessible to us. This is any application. Similarly, in terms of speed, we don't have sort of a hub and spoke model where you literally have to come back to home to go everywhere. And you'll see this in the demo. You can jump from app to app based on interfaces that they define. They can define, and that can be used by all. We also have a widget model. Here we have a search box by default on the screen, but you can also, I could add a different widget if I wanted to. I have a bunch of choices. So we really try to make it easy for the user to jump around and get at their information very quickly. I'm going to talk about multitasking next. I think it's a big advantage of Android. You can really run multiple processes at the same time. And this is also an opportunity to demonstrate some really what I think are cool third-party apps doing a lot of the stuff we're talking about. So there's one app called TuneWiki that is a music player. It replaces the the native music player, but it does some really cool stuff. Like, I don't know if you're going to be able to hear this, but it actually displays the lyrics of the songs it's playing. Can you hear that? Yeah, there you go. So it's actually gathering lyrics from the internet, creating a service for that, and their app draws on that, and based on the song that's playing, it can do that. Now, where it gets really cool is there's another third-party app called Shazam. This is a company that's been around a few years. They do music recognition, literally based on audio. So if you're in a bar or in the car and you hear a song you like, you hold it up and it tells you what the song is. So I could do this on a separate phone just as well, play it over the PA, but I'm going to just tag that song. Yeah, it is. So I could use two phones, exactly. And they're not using native code at this time, I think. I know they're planning on moving to that, so this will get faster in the future. So there's the app. It found it, and then various apps have defined interfaces that anyone with a song can jump off and use. So, here, let's go to YouTube, and here's a bunch of songs. Looks like Maroon 5 played on David Letterman. Now, we may get audio playing over audio at this point, so I'll probably just back out of this. And this is all, by the way, happening over the 3G connection. Yeah, so there's David Letterman about to introduce them. Can also go. Well, you got the.
Power management with everything potentially running without me realizing that they are.
I'm going to go buy the song on Amazon too. How do we do power management with everything potentially running? That's really up to the apps. We do offer functionality like wake lock and whatnot, but obviously that's a pretty expensive thing in terms of power consumption. So developers need to use that judiciously. And obviously, when you're playing music or when you have the screen and the backlight on, that's one of the most power-hungry things you can do.
So is there some way for me to at least account that my screen power goes to application name, so I realize that all my 3G power goes to application B, so I know which one to shut down if I realize that I'm running out of 2.
For the user, not in this release of the software. I don't think we. The question was, is there a way for the user to see kind of what the power consumption profile is? And I can't make pre-announcements here, but we're working on something like that. So, okay, so that's, so from that song, I jumped off to Amazon, and I could literally go buy the song here and download it to the phone as well. So, so we make it really easy for folks to jump around between apps when there's sort of common information that they can all share. And again, just showing you the notifications here, it's telling me I'm playing the song. So I'm going to jump back to that, and I'm going to pause that. Note that there's no actually notion of quitting the apps. I'm really just sort of jumping from app to app, and the system is really smart about memory, kind of managing the memory in the background. So if I go launch something big like the browser right now, that'll get kicked out of memory because the browser's pretty big in terms of memory footprint.
Can you clarify? Does that mean there's no way for an app to actually quit? Does that mean once you launch it, it's running forever?
So you can always go in the app manager and settings, and you can do it, but we want to make it so that the user can never needs to do that. It's more sort of a browsing model with the home and the back button. And what we do is when you run out of memory, the apps that are in the background get sort of freeze dried, and the state gets saved, but they come out of memory in that way. So that's. No, Dan, do you know the answer to that? Maybe we can take that in the Q&A. I don't know exactly what happens, but no, you don't run out of memory. No, but the worst case scenario is the only thing in active memory is the app running in the foreground. That's sort of the worst case scenario. That feels weird?
Yeah, probably because we're so used to the other thing.
Right. Yeah, I mean, you can always hold down the home key and actually see what's actively running if you want and jump to them. and there are third-party apps in the market where if you want that feeling of satisfaction, you can go do that, and you can go into settings and manage your apps in that way. But the goal is for users not to have to think about that. Yeah.
So your competitor wants the phone to also be your iPod, and I'm wondering, do you have that idea too, that this is sort of the only device in your pocket, and what are the implications for battery life and that kind of thing?
Yeah. So the question was, do we want this to be your only device? And our other competitors' approaches, I guess. I would say that there's different devices for everybody, and they all have different strengths. I think we've got great music player, video player, we've got YouTube, we've got all sorts of things. If you're really hardcore into one certain type of app or one type of media content you use, you're going to choose a device that works for you. But we.
I mean, can you play music all day without your battery dying?
Hours at least.
Yeah, hours. Right. So there are trade-offs, and by virtue of having a radio that's on all the time, there are trade-offs with all this stuff. Okay, so I'm going to jump now. I'm going to want to talk about. I think I showed you widgets before. One of the widgets that's really cool is our voice search, which is an app as well, but you can launch it from this. So I'm going to push this. Ethiopian restaurant, San Francisco. Okay. So what this has done is it's driven a web search base. You can see it recognized what I said, given us our mobile search results. By the way, the browser's using Google Gears, so it knows, this blue dot actually knows based on sort of my cell ID that I'm running on right now, the cell tower on, roughly the area I'm in. And you see a bunch of listings here. Notice the number isn't a link. Nor is the address, but you can see it gets outlined in green, or at least the address did. And so the system's smart enough to just pick up what our phone number. So I could call this now, or I can literally click the address and go view it in Maps. Here I'm in that mode, the satellite mode. And I could go and get directions to the address from my current location because it knows where I am. We have different levels of location. The default is to just do the low power option, which is know where you are based on the cell ID or the Wi-Fi ID if you're on that. But the device also has GPS, and we have a robust location framework that handles all that. So I can go ahead and get the route. Oh, it said it couldn't determine my location. Interesting. Well, I just reflashed this device, so that's probably why. But anyway, so you can do that. Yeah, and I could drill in and look around and see if it looks like there's parking nearby, or I could even go into Street View. We have Street View, and you can look around and identify what the storefront looks like. So a lot of cool stuff you can do there. And again, we're detecting those phone numbers and those addresses, even if they're not marked as links. The last thing I wanted to talk about was kind of future direction for bridging the physical and the electronic world. Let me see if I have I don't know if it'll recognize this barcode, but we've got a barcode scanner that's on the market, and you can use it to basically, I actually don't know if it's going to recognize this barcode, but let's see what happens. It is not recognizing that barcode. Does anyone have a soda bottle or anything with a barcode? Here, I'm going to take this. There we go. So say I'm at the store and this looks really cool. There we go. So I can open product search. Here's your used package, sir. Linking off to the browser to product search. And oh yeah, look, it found it. Sensible Foods, Apple Harvest. Yeah, and it really gets more interesting from here. I think barcodes are just the beginning. I'm really interested to see what happens more in sort of the augmented reality world. So we have this thing called Google Sky Map, where let's see. Yeah, here I'm actually looking down through the Earth because the projector is. The projector is only pointed down. But I'm basically using the location sensor, the accelerometer, and the compass to tell me where I am, and I can basically overlay information. Another great example, and this one will be harder to do on the screen, is this thing called Wikitude, where we take where this third-party developer takes all the Wikipedia entries that have GPS coordinates associated with them and overlay them either on a map or in this case on the camera. So getting back to sort of the augmented reality thing, now this will be hard to do, but let's see what happens. What was the question? Sorry. Is the voice? Yeah, I made your point. Voice search is pretty good. I mean, it depends on. I'm gonna not get that now. It depends on. So let me do one thing at a time, actually. So I have to kind of do an angle here because it wants me to do it in landscape mode. But you see, I have sort of a little radar thing at the bottom, showing me where there's things, and then it should overlay. Yeah, this is too tricky. Basically, in camera mode, it will overlay. It's actually overlaying points and with markers on them. I'm happy to show this to anybody afterwards if they're interested. And there's the Pleasanton Mall, and there's San Jose State University and whatnot. So you could be on a mountaintop and do this and sort of look around and actually points things out for you and overlays it on top of the camera. So I think there's a lot of interesting stuff that could be done there in the research area and whatnot. Okay, I think we're just about out of time. So Jeff was going to come up and talk. Here he is. Talk about some mobile project.
So I'm a late addition here. I asked, thank you, David and Dan, if I could join them, because I guess about 6 months ago, I asked Alfred if we could donate some Androids to some university faculty and to see what they could do with them. And he said, yes, let's do an experiment. So I guess we donated about 200 to maybe a dozen or a couple dozen universities. And I didn't expect much results, but I just pinged them early this week, and they sent me some of their, each of them sent me a slide. So I wanted to just show you some of the things that are going on in the universities using this platform for both education and research, and also get your feedback. Is this something that would be of interest if we did more of it? To me, this platform, I was at Intel during the 90s, and it's hard to believe now, but when we started, there was really no PCs in the academic computing centers. That really started about mid-1990s, and it really, before then, there was just about a dozen different kind of workstations, and it was hard for folks to communicate. But we donated, tens of thousands of computers and PCs, and I think now we're ushering in a new era of maybe not personal computing, but maybe everybody computing. And I think this kind of fits in with our theme for Inform and Empower Global Connections. And that's one of the reasons why we wanted to have the Android talk, because in addition to creating content through the Books project and communications through language translation, we do think this Android platform will be the platform or platforms like it, the way most of the people are introduced to computing throughout the world. Anyway, some of these projects actually are looking into those issues, and I just want to quickly run through them and then get your feedback and see if we should do more like this. This one's out of North Carolina State, Professor Frank Mueller, and this is fairly traditional kind of a thing, ad hoc networking. It's a student class project. We have a lot of class projects. And this one's kind of doing some interesting things. There's a lot of senior project classes we've seen. This one's out of MIT, and I believe this might be the School of Architecture. But Eric heads up one of their educational programs, and they're creating a game for students to learn about weather. And I thought this was a pretty interesting one. I want to see this one actually working. Columbia. Professor Steve Feiner is working on augmented reality. Now, he's been doing this for a dozen years or so on PCs first, and now switching over to the Android. And as you can see, it's using GPS and data provided by New York City. And kind of reminds me a little bit, it's sort of scary, a little bit of Minority Report, where you're presenting these things onto the screen. But fascinating research nonetheless. This is another project, sort of reminds me of our Android App Inventor. It's, this is for middle school children, and they've deployed it in 300 locations, underserved communities, and all the students' programs run on the Android. So it's kind of another exciting development on the educational front out of Brown. This is one project that I must admit I don't fully understand. Or the motivation for it. But whenever I see something like that at the university, it interests me, and it bothers me so much that I want to keep learning about it. But this is an HCI professor who is creating this project called Spin, and somehow the Android, the phone, monitors videos, does audio of knitters, and captures that whole experience. And then when the artifact is created, the actual digital artifact is given with it, and it captures the various moments, the conversations that went on. I should probably. Anyway, oh, yeah, right. Anyway, okay, please do. Okay, here's another one. Social networking is big, and then I like this one, RecWatch. Whenever we're on our way up 101 and there's an accident, it'd be nice to know that to switch over to 280. So this would be a good, useful project. Another more augmented reality. This might be my favorite one. Some of you may know I lived in Pittsburgh for a few years. And they're calling it YINSCAM. And YINS is some kind of Portuguese term for you all or all of us or something like that. And what it allows you to do is to sit in the stadium and get various views of the action. Even if you're way, way up in the rafters, you can see replays and, basically see the goals scored and so forth. So this was a really enterprising. I think actually they're going to try to make a company out of this, but I could show you the video, but we really don't have time, but I encourage you to look into that. Everyone knows Richard Ladner at University of Washington, and he's using the Android for mobile access for folks with disabilities and so forth, and it's another exciting project, and Richard also has a Google Research grant. Srini Session, who's here today, is working on privacy and Androids and mobile environments, which is, I know, a real concern of a lot of folks, so that's also exciting. And then we have Deborah Estrin, who's here. Deborah is the only one that has 2 slides because she has 2 projects and actually we're funding Deborah through a research grant as well as and giving her some Androids. But this participatory sensing project is one of her projects. I kind of like this one about the idling trucks. Living in San Francisco, waiting for the Google bus, and that's a good thing. So I think the citizen science is another interesting area. And then the other project I just called Wellness, but it's basically monitoring chronic diseases and basically putting your health back into your own, having yourself monitored via your Android or your mobile phone. So that's a really good one as well. Anyway, those are just some examples, probably about half the projects we've funded earlier this year. So I'm anxious to hear your feedback. Is getting this kind of platform useful for you in your education and research? Should we do more of it? This is a little bit different from our research grants. It's an equipment grant. So we definitely like to get feedback on that. Feel free to send me email or anyone here on our staff if we should encourage that.